Hello students, welcome to Eduxcite classes. In today's session we'll discuss topic 8. It's a small request before we start that please solve this worksheet and then watch this video. The PDF you can find in the link is given in the description. Okay, so without wasting time, let us start. So question number 1, the degraded energy is the energy that is A, stored in the Earth's atmosphere, available from non-renewable energy resources, converted into work in a cyclical process, or the no longer available for the performance of useful work. Now we know that the degraded energy stands for that which cannot be used for an useful output. Okay, so that will be no longer available for the performance of useful work. Okay, so now next question. The Sankey diagram is given to us. Which of the best identify the thermal energy removed by water and the useful electrical energy output of the station? Now when you look, this is always the output, useful output. Now we know that in an electrical energy output we want, so electrical energy output will be 1. Yeah, so this and this gets incorrect, so we have to think in terms of A and C. Now look, the thermal energy removed by the water, that is the major you can say the energy that is being discarded or is not useful. So second will be the removed by water. So the first option A will be the right answer. Okay, question number 3 now. Which of the primary energy uses in the world? Okay, so there are 3 energy: coal, nuclear and geothermal. So we know that right now at this stage we are using the coal as the maximum, then the nuclear and then the geothermal because it is there are certain limitations, because we cannot use the geothermal at each and every specific location. There are certain locations there only we can utilize the or use the geothermal energy. So as per my findings, the coal is the maximum, then nuclear is 10.1% worldwide and geothermal is around 8.3%. No need to remember the data, but just to give you a further information. Now question number 4, which of the following correctly shows a renewable and a non-renewable energy? Okay, this is very simple. The ocean waves and nuclear, because uranium is found in a limited amount on this planet, so uranium are used as a fuel for the nuclear, which is a non-renewable. Question number 5, which of the following energy sources result from the solar energy incident on the earth? Now nuclear, as we discussed, uranium. Geothermal, as I mentioned, that is the heat entrapped within the surface of the earth crust. Okay, so that is nothing relation with the solar energy, that is also get cancelled. So the remaining option is B. Now what happens, how does the wind create? Now wind is because of the sun's radiation that falls on the earth, it creates a difference in the pressure. Due to that difference in the pressure, the air molecules move, and that we call it as a wind. So wind energy is an indirect energy from the solar energy that we are receiving. Okay, so B is the right answer. Now a coal-fired power station has a power output of P and efficiency is small epsilon. It burns a mass of coal m every second. The best estimate of the specific energy of the coal will be. Now what is the specific energy? First of all, specific energy is nothing but you can mention as the energy per unit mass. That is the energy received, or you can say the energy contained in that particular resource or the material that we are using. So specific energy is the energy per unit mass. Okay, now first of all, this is the specific energy I am denoting with symbol rho. So can I say like energy, this is the energy input is equals to rho into small mass m, and energy per unit time, if I divide per unit time, so energy per unit time is power input, power is energy per unit time, so power input is rho. Now also m over t, if you look, this is given in this, the mass of coal every second is denoted by capital M. So can I write rho into capital M as power input? Now efficiency is what? Efficiency is power output upon power input, right? So power output is mentioned as P, So I write P and power input as rho into m, where rho is the specific energy. So from here, can I write that specific energy is P over efficiency times capital M. So that is option D. So I hope this is clear. If you have any doubt, you can comment below. I will try my level best to clear all your doubts. Now moving on to the next question. Which of the fuel has the highest energy density? Now again, we know that highest energy density of nothing but uranium. So no need to mention, but I will give you some data I have researched. Like coal is 24 megajoule per kg. So if you are using 1 kg of coal, that can generate an amount of energy equivalent to 24 megajoule. And for gas, it is something around 55 megajoule per kg. And for oil, it is 45 megajoule per kg. And uranium, it is 3900,000 megajoule per kg. So you can compare the data. This is the maximum. Okay, so uranium can produce 1 kg of uranium can produce 3900,000 megajoule for 1 kg. Okay, now the overall efficiency of a typical coal power plant is, we know that it is something around 30%. So this is the right answer. The efficiency of modern natural gas is relatively higher, which is 50%. So these are certain efficiencies that you should remember. The generally used power stations efficiency. Okay. Question number 10. The design of a nuclear power station includes an electrical generator. The function of the generator is to convert. Now always remember, when we are asking about the generator always convert your kinetic energy to your electrical energy. Simple. It is not asking you about which power plant it is being used. It is not having a relation with any power station which is using an electrical generator will always convert your kinetic energy into electrical energy. So do not get confused. Okay. Now question number 11, this is a direct question from nuclear power plants. What is the role of moderator and the control rod? This is very important from your paper 2 point of view as well. So you should know the moderator slow down the neutrons, and control rod maintain a constant rate of fission, which is option A is the right answer. Okay. Now critical mass. What is critical mass in case of a nuclear fission reaction? It is the minimum amount of mass which is required to continue the chain reaction. Okay, the minimum mass required to continue the chain reaction. Okay, to continue the chain reaction. So if the amount of uranium, if it is less than the critical mass, then your reaction will stop after a certain time, and you will not get the power or the electrical power continuously. And if it is very much greater than the critical mass, then also it is very dangerous, because it can be converted into an explosion or an uncontrolled chain reaction which will produce a huge amount of energy. So that has to be very precise just to maintain the chain reaction to get a particular amount of power output or the electrical energy that we are getting. So the option will be the minimum mass necessary for the reaction to will allow the fission to be sustained. Okay, the continue the chain reaction means to be sustained. Sustain means continuous. So option A. Question 13. In a nuclear power station, uranium is used as the energy source for plutonium-239 is produced. Which of the following is true? So uranium is used as the energy source, no doubt, but plutonium-239 can also be used as a fuel in another type of nuclear reactor. So that is option D is the right answer. Okay. Now question number 14. Energy changes in photovoltaic cells. This is very common. Photovoltaic cell and solar heating panel. So photovoltaic cell directly converts solar into electrical, and heating, as mentioned, solar into thermal. So option A is the right answer. Now question number 15. Water is contained in tidal basin behind a dam. The water has a depth h at a high tide, this is the high tide, and zero level at the low tide, as shown in the diagram. The gravitational potential energy of the water stored in this basin between a high tide and low tide is proportional to. Now, in this type of question, you have to make sure that you find out the relation correctly. Okay, so let us say the gravitational potential energy is what, mgh, and the mass stored, let us say the area of cross section is a, this is height, so this is this I can say this is the base, and this is the I can say this is, let us say, length. Okay, and this is the height as is given. So mass can be written as density into volume. Density is mass per unit volume, so it can be written as into volume into g into h. This is what, this is my gravitational potential energy. Now volume can be written as length into, this can be volume length into height into, so then volume can be written as length into breadth into height, because this is a cuboid shape. So this you can say this is breadth and this is the length, let us say. So this is the volume, or length into breadth is the length into, this is the dam. So yeah, so this is into h, right? So this is your area of cross section, or you can say this is a constant. Okay, so you can say length into breadth is constant into proportional to h square is gravitational potential energy. So I can say gravitational potential energy is proportional to h square, which is option C is the right answer. Okay, now question number 16. The wind turbine power has P. This is directly based on your formula rho a v cube, right? This is the power, and how we get this is in another way, that is nothing but kinetic energy is again half mv square, right? So kinetic energy per unit time will be power, which will be half mass can be written density into volume into v square. Volume can be written as area into velocity into v square. So this is half rho a v cube. So we get this. Now if the velocity is twice, so 2 v cube will be 8 v cube. So the power will be 8p. So option D is the right answer. You just have to equate your velocity get double. So double cube will be 8 times. So 8 times will be the power of the if the wind turbine increases its speed by double. Okay. Question number 17 now. This is again based on a black body Stephen-Boltzmann law. I hope you know the formula just given in your data booklet. Power is equals to emissivity sigma into a t raised to power 4. Emissivity, and this is the Boltzmann constant. This is the area of cross section. This is the temperature. So it is given that surface X has temperature Tx and emissivity Ex, and surface Y has Ty and Ey. The two surfaces emit radiation at the same rate. So the power of Px is equals to Py. So Ex sigma a Tx raised to power 4 is Ey sigma a t raised to power 4. So these are constant. Okay, so Ex over, or you can say Tx we have to find out. So Tx over Ty raised to power 4 is equals to Ey over Ex. So Tx over Ty is equals to Ey over Ex raised to power 1 by 4. That is option A. This is a simple mathematical calculation. Okay. Now question number 18. The diagram shows the variation of the wavelength of the power per unit wavelength I radiated from an area of 1 meter square of two different bodies, which of the correct comparison of the temperature and the emissivity. Now this is very important, you should know. Now the peaks are different. Okay, so peaks are different, they have different wavelengths, so it means they have different emissivity. Now these are having different you can say they are not one over the other, so they are not having the same wavelength, or the temperatures are also different. So you can say they both are different. So if the temperature and emissivity is different, they will perfectly align, which is not the case here. Perfectly aligned is not here. Now temperature is what you say, temperature is same, so they will have a common wavelength, peak wavelength, which is not the case. Now temperature is different, so they will have, the higher the temperature, it will be different peaks, but the intensity will be different, right? So that is not the case. So in this case, the temperature is also different for both, and the emissivity is also different for the both. What is the phenomena that best describes why greenhouse gases absorbs infrared radiation? Now this is a direct question, which is known as the resonance effect, or the phenomena of resonance. When what happens when the radiations are radiated from the Earth's surface, it is generally in the form of infrared radiation. Now the gases present in the atmosphere. Now what happens is, these frequencies or the wavelength matches with the frequencies of the greenhouse gases, which ultimately reflect back to the Earth's surface. So that result in the global warming or increase in the average temperature of the Earth. So that is known as, when the frequency matches with the gases, molecules or the other particles present in the atmosphere, that is known as the resonance. Okay. Now question number 20, greenhouse gases. Now greenhouse gases is simply the transmission of ultraviolet radiation, but the absorption of infrared radiations. So here also these absorb the infrared radiation and reflect back into the Earth's surface. So that is also a direct question. Option D will be the right answer. Now question number 21 is a misleading diagram. This diagram should be like this. The intensity coming is this. Now always remember, whenever we are discussing about the albedo is the scattered power, or you can say the reflected power, okay, upon the incident power, not the radiate power, incident power. So here the alpha will be, the reflected one is 0.25 plus 0.15 of I upon the incident is I. So this is 0.40, which is option C. Radiated will not be the part of the reflect. It is not reflection. Radiating means they are radiating in the form of electromagnetic waves, which is not the part of the albedo. Albedo is the ratio of the reflected from the surface to the incident radiation, or the intensity received on the Earth's surface or the planet's surface. Okay. Now question number 22, in which of the following places will be the albedo be the greatest? This is a direct question. 0.85 is the maximum for polar ice cap. And if you want to know about the other, I have researched that as well. No need to remember, but you should know that for the ice it is 0.85. It means it reflected the most, and that is why they are bright enough. Okay, so they reflected the intensity or the radiations the most as compared to the absorption. Whereas the forest is something around 0.1, grassland is 0.25, and the ocean is 0.06, something like this. So the highest is for the polar ice cap. Now the large area of rainforest are cut down and burned every year. These are the result of the increase in what? The carbon fixation. They will reduce the, because what happens is the rainforest and the forest and the trees reduce the carbon dioxide and produce oxygen. If they are cut down, then the amount of carbon present will increase, and as the greenhouse gases increase, and as a result the global temperature increases. So what will happen is, this will reduce the carbon fixation, which fix the excess amount of carbon dioxide or the carbon present in the atmosphere. So that should not be, this is nothing but the deforestation. Okay. Now question number 24, most climate scientists agree that the enhanced greenhouse effect is due to the burning of fossil fuel, because they releases greenhouse gases. It's a direct question. And the last one, the collision of the molecules within a substance is the result in the transfer of energy by nothing but conduction. Okay, so that's all from topic 8. I hope you have received all your doubts get clear. In case if you still have any doubt, just comment below. You can find the PDF of this video also in the link given in the description. All the very best for your exam. Keep learning. See you in the next video.